Okay, the line has an equation r equals to 4i minus 6j plus 12k plus this is a position vector. So what the a in that position vector, the line equation of the line, together with lambda. This will be the m, the direction vector of the line. Okay, to find the position vector of the point where your line meets the plane x equals to 0. So basically, you have the plane. This could be the plane where x equals to 0. Right, and the line over here, this intersects. So we're actually finding this point intersection. Right, also our line here is none other than r, which is equals to 4, negative 6, 12 plus lambda 1, negative 3, 2. Right, where lambda is a real number. Okay, so from there we need to find the position vector. So very easily, let's just look at maybe part 1. Okay, with x equals to 0, x equals to 0, this means that generally, right, your coordinates on this plane, right, are of the form, since x equals to 0, that means you have the coordinates should be look something like that. X equals to 0, y could be any number, z could be any number. So your coordinates, right, on the plane should look like this. Okay, and for you to intersect with the line, right, that means your coordinate must satisfy two types of equation. Number one, there exists, that means there exists x, y, z that satisfy number one, L r equals to the 4 negatives, right, which is satisfy the equation of the line. Okay, number two, you must also satisfy the equation of the plane, and the equation of the plane is just x equals to 0. Right, so for you to satisfy both, right, for you to satisfy both the line and the plane, right, that means, right, that means your x, y, z must satisfy both. So if we just take the equation of the plane, we satisfy the equation of the line, then we are almost done. Okay, so no, for the line, right, you can see that for equation of the line, x is equals to 4 plus lambda, y is equals to negative 6 minus 3 lambda, and z is equals to 12 plus 2 lambda. Okay, and comparing this with the equation of the plane, suppose we to solve this simultaneously, right? To solve this simultaneously, right? Very easy. This means that if we want our coordinates to satisfy both, if we sub the equation for the line to the plane, that means we also say that we want this, the equation x equals to 0, right? We also want this x equals to be 0. So this means what? This means that if I combine this and this, alright, this gives me that 4 plus lambda will be equals to 0. That means, right, for at the point intersection, right, where you satisfy both equation of line and plane, right, your lambda is negative 4. Okay, so from here, right, we can find lambda is negative 4 easily. Once we find lambda is negative 4, using substitute this, that means your y is equals to negative 6 minus 3, lambda is negative 4, right? Negative 4. Y will be equals to 6. Okay, z equals to 12 plus 2, lambda is negative 4 again, so it's 12 minus 8 equals to 4. Okay, and very quickly, taking my coordinates, x is 0, y is 6, z is 4, right? The position vector of the point of intersection of the point is nothing but 0, 6, 4 is 0, 6, 4. Okay, and this is for part A. For part B, alright, we are looking at the position vector of the point where L meets the xy plane. Okay, so on the xy plane, right, number one, first thing I can assume from the xy plane, it means what? Your z coordinate has to be 0. It means in your vectors on the xy plane, right, I can just say that this is just a plane. This is where z equals to 0. Okay, how about the original line? The line equation gives us r. Okay, let me just write it in this way. This is the same as 4, negative 6, 12 plus lambda 1, negative 3, 2. Okay, where your lambda is a real number. Okay, so from here, again, what we do is we try to solve them simultaneously. Alright, so if we compare our equation, okay, we can see that since z is equals to 0, we can also assume that our third equation, which is the variable, right? So if you break this out again, we have 4 plus lambda, x equals to 4 plus y equals to negative 6, just like earlier on. z equals to 12 plus 2 lambda. And if we solve them simultaneously, it means that we want this, right, to be equal to 0, because we want the intersection with the plane. Right? So when z equals to 0, we have 12 plus 2 lambda to be equal to 0. This means that your lambda should give us a negative 6. Okay, and this means that at the point of intersection between the line and the plane, your lambda is negative 6. And since your lambda is negative 6, we can easily find the x coordinate. This means that here, x is equals to 4 plus negative 6, which gives us negative 2. Over here, y is equals to negative 6 minus 3, negative 6 again. Okay, I'll leave the presentation up to you to give you 12. Right? And combine your answers. Z equals to 0, x equals negative 2, y equals to 12. The position vector of the point is none other than negative 2, negative 2, 12, 0. Okay, so this is the position vector of the point of intersection. Okay, how about for part 3? Okay, so the part 3, right, we are looking at the x-exact plane. The x-exact plane actually is nothing but on the x-exact plane, this means what? On the x-exact plane, right, all your y coordinates are 0, right, because we are looking at x-exact plane. Alright, total x-exact plane, your y coordinates have to be 0. Okay, so actually it's just a plane. It's a plane where y is equal to 0. Okay, similar concept to how we approach part 1 and part 2. Alright, recall the equation of the line. We have the equation of the line over here. Alright, x equals to 4 lambda, 4 plus lambda. Right, y is equals to minus 6 minus 3 lambda. Z is equals to 12 plus 2 lambda. Alright, okay. Alright, so, sorry. Okay. So with that, right? So with that, we are looking at y to be 0. This means that we equate the second equation, right? I'm looking at this to be 0. This means that we have y to be negative 6 minus 3 lambda, right? This is equal to 0. Okay, and since it equals 0, very quickly you can see actually from here, if we equate this to 0, lambda will give us negative 2. And from the fact that lambda is negative 2, x will be equal to 4 plus lambda, so 4 plus negative 2 equals to 2. Z will be equal to 12 plus 2 times negative 2 equals to lambda, so it's equals to 8. And very quickly, combining my answers, right, y equals to 0, x equals to 2, z equals to negative 8. Alright, the point, right, of intersection, okay, the position vector of the point of intersection, right, it just equals to 2, right, x equals to 2, y equals to 0, and z equals to 8. Alright, and we are done for PQ question 3.